imagine the future of the Internet of Things without electricity. If you go outside and take a look at the equipment that we have in the field, you see that it's usually very ugly old equipment. Underneath where you're sitting, you have a transformer from 1936. So we are banking all of this event to a transformer from 1936. At the same time, we are experiencing a huge transformation with smart grid, right? So there's this two speeds that we are dealing with, and one thing has not changed very much, and that's the frequency of very large blackouts, right? So if you think of 2003, in the northeast of the US, 50 million people lost power. In 2012, the big cascading events in India left without electricity 10% of the human population. So as we are thinking about that here at Oregon State, we are trying to leverage the smart grid technology in order to understand what are the mechanisms for which these blackouts propagate. So we're trying to understand how cascading outages propagate and what are the main mechanisms. We are using some smart grid technology called synchrophase or a phasor measurement unit. So we are basically getting voltage transformers and current transformers, and we are getting a GPS timestamp so that we can time align those voltage and current signal so that we can see what is the sequence of events. And here at Oregon State, we are connecting this synchrophase very, very close to our load pattern. So our campus is behaving basically as a test bed, and we are learning more about how loads are behaving with this Internet of Electromechanical Things. And I'm calling it Internet of Electromechanical Things because you can see how in this rack right here, we are basically having an electromechanical or microprocessor relay that now is interacting with an IP address where we are getting this data at 60 hertz. So we are basically converging these two worlds that it's becoming very, very critical that we make secure. So with this type of technology, we are learning things. For example, that the type of load that we are putting our models is very, very critical to try to predict how that blackout is going to propagate, right? So if you don't consider reactive power, for example, you will see that the first sequence of events are very, very matching with some other more complicated models. However, if you remove that reactive power, those paths that we are predicting will diverge. So this is the research that we are doing here, one of the focuses that we have, and I'll be happy to take any questions and keep working to keep the lights on.